Welcome to Systems Are Go. My name is Eric McLaughlin and I'm the astronomer for the Rancho Mirage Library and Observatory. In this edition, we will explore not only the data from the end of November and all of December, but we will also be looking back at some of our data from throughout last year. So, as always, sit back and enjoy these views and data from our observatory. and boom. That bright streak is a Geminid meteor. Our camera does not catch most meteors, but this one was particularly bright. Other than the night it fell on, the main indication that it is a member of the Geminids is that it appears to trace back to the constellation of Gemini. Alright, back to it, and I will check in with you on the night of the winter solstice. Now as we head into winter, let's pause. That light just over the mountains is actually both Jupiter and Saturn. A conjunction of these two planets is visible from the Earth roughly once every 20 years. We were live streaming at the time and took a series of images which I stacked and processed to make this image. I then brightened sections of the image to make some of the moons visible. It really was quite a sight. Thank you to everyone who helped make it happen and who were there watching with us online. And back to the time lapses. As we wrap up the night sky views for last year, we'll look back in a way that allows us to view the sky in a different way. By taking images from midnight on each night, we get a time-lapse that allows us to see how our sky shifts from night to night. Because of the Earth's motion around the sun, exactly what is up at midnight shifts slightly from night to night. The weather data for November and December shows that temperatures really seem to have stabilized from the end of November onward. Now, while I was not able to get all of the temperature data from the year into this graph, most of it is there and we can clearly see the full arc of the seasons. Onto our heat maps. These show temperature for every day as a column which progresses upwards from midnight through the day to evening at the top. In our views with the color mapping scaled from 0 to 50 degrees Celsius, the variance is quite low for both months. That is why we have another color map scaled to the temperatures seen in each month. Why then do we have the 0 to 50 scale? Because it's great for looking at the bigger picture. Here we see most of last year. The area between the vertical green lines are on daylight saving time, while the area outside them is on standard time. This unfortunately obscures some interesting features of the data. For example, the coolest hour of the day typically occurs in the morning just before the sun rises. This hour is thus later in the winter and earlier in the summer. However, because the summer data here is shifted up for daylight saving time, that effect is not as obvious. Finally, we have some upgrades for our temperature humidity scatter plot. I added a number of reference lines showing the water content of the air. These were made with a derivation involving the ideal gas law, the definition of relative humidity, and a neat little empirical equation called the Burke equation. I've also animated the plot so we can see how the humidity and temperature evolve throughout each day. I've stated in previous videos that if on a given day the water content in the air does not change very much, then we can expect the points to make lines going from the upper left to the lower right, and back again. Now, with the water vapor density contours plotted, we have a more quantitative reference to look to as these points are plotted. With nearly a full cycle of the seasons plotted, let's try brightening up those colors to be better able to discern when a given point comes from. And finally, we would not have a definition of a year were it not for our orbit around the sun. As usual, these images are taken with our H-alpha solar telescope and have been colorized to show more detail. H-alpha refers to a very specific wavelength of red light that comes primarily from the sun's chromosphere, an area just above the visible surface of the sun. We have been starting to see a few more sunspots and activity, but the sun is still relatively quiet. Sunspots are slightly cooler areas of the sun which have a high amount of magnetic flux passing through them. These are known as active regions on the sun and are often the kinds of places where solar flares and coronal mass ejections originate. Enjoy these views, and I will be back for a couple more highlights as we close. As we crossed into the new year, we also reached perihelion on the 2nd of January, the closest point to the sun in our orbit. On July 4th of last year, we reached aphelion, the farthest point from the sun in our orbit. Unfortunately, we were not observing on either of those days. Nevertheless, we do have images from days near them. Thus, we can compare how large the sun looks from those two vantage points. In short, the sun looks larger on one view because the picture was taken about 5 million kilometers closer to the sun than the other image. To wrap things up, here is a time lapse of one image a day from our entire solar telescope imaging from last year. Thank you for joining us for Systems Are Go, and a special thank you to the Rancho Mirage Library and Observatory Foundation for making programs like these possible. We hope you enjoyed your time here today. If you'd like to be kept up to date on all of our programming, follow the link in the description below to sign up for our eNewsletter. We wish you a happy new year, and as always, remember to keep on looking up.